Hey guys, today we're going to learn how to find the volume of a solid that is made out of revolution. So here we have an example. We have here this graph of some function f of x. Now, if we bound it from the x value a to the x value b and then rotate it around the x-axis, what we get here is this solid. Because if you just continue to rotate it and you draw like circles, basically you would end up with a shape like this. Now, when you think about it, right, if you cut a slice out of this figure, like if you just cut it through here and you look at it from, I guess, the side, what you see would be a circle. So what happens is that in order to find the volume of this solid that is created, this is called the disk method. And it's called the disk method because the representative slice would resemble a disk, which is exactly what we see here. The volume of the solid is then found by integrating the area of the disk from x is equal to a to x is equal to b. So this is the equation. Volume is equal to the integral of a to b of the area of the disk dx. Now because the disk resembles a circle, the area of the disk is denoted by pi r squared because that's the area of a circle. Now pi is basically a constant, so we can move it to the outside of the integral, so it looks like this. And then the radius of the circle, that's this part here. This is the radius, which is, here on the 3D figure, we can see it here, the radius. And if you go around through the whole figure, the radius changes, and it all depends on the function. So that's why when you're actually integrating, the radius is found by taking f of x and subtracting it from the axis of rotation, which if it's just the x-axis, the axis of rotation would be 0 because the x-axis is y is equal to 0. So when you are rotating, the radius is f of x, which is the y, minus the axis of rotation, which is the x-axis, which is when y is equal to 0. So that's how we would find the volume of this solid. So let's actually focus here on this particular function. We have that y is equal to x squared minus 4x plus 5. And we want to determine the volume if it's bounded by y, x is equal to 1, and x is equal to 4, and the x-axis. And it is rotated about the x-axis. So here, this is the axis of rotation. So that means that when I rotate it, so you can get a visual, what I do is that I reflect these points over to the other side of the axis of rotation. And it would look something like this. And then to kind of, like I said, get a 3D figure, what I do is I just start drawing out these discs. So this is my solid. So here's the formula that we're going to use for the volume. So that means that volume is going to equal to pi, the integral from 1 to 4, because remember your limits of integration are always the x values. And then the radius is going to be the function minus the axis of rotation, which is 0. So our function is x squared minus 4x plus 5 squared dx. So keep in mind, remember that the radius is always squared since we are integrating the area of a circle, so pi r squared. Now just in case, right, you don't necessarily have to remember this formula. As long as you know that the area of a disk is the area of a circle, then it's pi r squared. You know, you can move the constant to the outside, so this would just be the radius squared. So when you're looking at your function here, or your 3D figure, because I always like to draw it out, I look for the radius of one of those circles. And this is my radius. And then I try to determine how to find that radius, which is the function minus 0. So that's why it's x squared minus 4x plus 5 minus 0, which is just itself. So squared. Now in order to integrate this, I will have to distribute. So I will have to do x squared minus 4x plus 5 times itself. So that's exactly what I'm going to do first. We have x squared minus 4x plus 5 times x squared minus 4x plus 5. So let's go ahead and distribute everything and work that out. So this is going to be x to the fourth, because I'm distributing the x squared first, minus 4x to the third, plus 5x squared. Now I'm going to distribute the negative 4x, so minus 4x to the third, plus 16x squared, minus 20x. Now I distribute the 5, plus 5x squared, minus 20x, plus 25. So now we're ready to combine like terms and rewrite this integral. So once more, volume is going to equal to pi times the integral from 1 to 4 of x to the fourth, minus, then we have this negative 4x to the third minus 4x to the third, which is minus 8x to the third. Then 5x squared plus 16x squared is 21x squared, plus another 5x squared is plus 26x squared. Then negative 20x minus 20x is minus 40x. And then finally plus 25. Now we're ready to integrate. Now the integration process within itself is not too difficult because this is just a regular polynomial equation. So we're going to add 1 to the exponent and divide by the new exponent. So we get that volume is going to equal to pi. Now I can leave this pi outside and just multiply it at the very end. I'm going to open a bracket here so I can integrate. So this would be x to the fifth over 5 minus, this will be 8x to the fourth over 4, so 2x to the fourth, plus 26x to the third over 3 is just 26x to the third over 3, since I cannot simplify that, minus 40x squared over 2 is 20x squared, plus 25x, and I'm going to evaluate that from 1 to 4. So now I'm going to take the 4, plug it in, and then to take the 1, plug that in, and subtract. So we get volume is equal to pi. Let's plug in the 4. 4 to the fifth is 1024 over 5. Minus 4 to the fourth is 256 times 2 is 512. Plus 4 to the third is 64, and 64 times 26 is 1664 over 3, minus 4 squared is 16 times 20 is 320, plus 25 times 4, which is 100. Now I'm going to subtract for when I plug in 1. So I'm going to open a parentheses now to remember that I will have to distribute that negative. So this would be 1 over 5 minus 2 plus 26 over 3 minus 20 plus 25. Now here's the thing when you have these fractions. What I like to do is before I find a common denominator, I like to combine everything else around it. Since I have fractions here with the same denominator as well, before I combine these, I'll distribute the negative and I'll combine it with these fractions here, and then I'll get my common denominator. Sometimes it just reduces the workload, and also sometimes it would actually be divisible, so you wouldn't necessarily need a common denominator. I'm not sure what the situation is going to be now, but we'll find out. So let's work this out. So we have the pi. We have the 1024 over 5. I'm going to combine these numbers together. So negative 512 minus 320 plus 100 is minus 732. Then I have this plus 1664 over 3. I'm going to subtract 1 over 5, and then minus 2 minus 20 is negative 22, plus 25 is plus 3, plus 26 over 3. So now I'm going to distribute this negative, and I get pi times 1024 over 5 minus 732 plus 1664 over 3 minus 1 over 5 minus 3 minus 26 over 3. Now I'm going to combine what I can. So this 1024 over 5 minus 1 over 5 is going to give me 1023 over 5. This negative 732 minus 3 is negative 735. And then this 1664 over 3 minus 26 over 3 would give me plus 1638 over 3. Now I will have to put this over a common denominator, which is going to be 15. So I have to multiply this by 3 and this by 3. I have to put this over 15 and multiply this by 15, and then multiply this denominator by 5 and this numerator by 5. And that would give me pi. 1023 times 5 is 3069 over 15 minus 735 times 15 is 11,025 over 15 plus 1638 times 5 is 8,190 over 15. So now we're going to combine all of these numerators. 3069 minus 11,025 plus 8,190 gives me that pi on the outside times 234 over 15 pi. Oops, I already have the pi there. Which this can be simplified actually by 3. And so I end up with a final answer of 78 over 5, and then of course the pi. And this would be my final answer for the volume of this solid. Now let's look at how to find the volume of a solid that has a hole in the middle. And I have here, now imagine for a moment what the solid would look like if the axis of rotation was still the x-axis, so we're still going to rotate about here, but the bottom function of the region was the line y is equal to c. That means that the solid is not only bounded by the function and these two x values, but also this y value. So that means that the only solid part of the volume would be this here. When I actually rotate it, we would have a hole because this is not going to be solid. And that's what it says here. The solid would look similar except for the fact that there would be a cylinder cut out of the center. And I'm going to draw this out so you can see exactly what I mean. If I'm rotating about the x-axis here, and this is the only part that's actually shaded in, then I'm going to reflect it along my axis of rotation. So this is 2 units away, so this is the solid part here. And then we have the function here and here. So this is also solid. And then we end up with this figure like this. So you can see that the actual solid part is just this. And to kind of like draw out these discs here a little bit, it's not necessarily a disc anymore, it is a ring. Because we have this solid part. I'm going to fill this in a little bit more so you can see. And then we have this empty part here. So look at how this kind of looks like a donut or like a washer. This is called the washer method because it looks like a washer. Okay, to find the volume of this solid, we would have to find the volume of the whole solid. So you have to find this area here and then subtract from the volume of the inner circle, which is that cylinder. So when we're trying to figure out what the volume is, it's the whole thing minus what's empty. So when we're finding that volume, this would be your formula. It would be pi, the integral from a to b, Capital R is talking about the big radius, the radius of the big circle. So if this is my axis of rotation, this would be capital R. And then little r would be the radius of the little circle. So this would be little r. So that's why we do big R squared minus the little r squared. So, and to put this kind of like more plainly in a formula that you may just refer to, it's the outer function, always the outer function, first, minus the axis of rotation squared, because that's our big radius, minus the inner function minus the axis of rotation squared. So that's big R squared minus little r squared. And of course it's squared because this is the area of a circle, which is pi r squared. So let's try out this exact problem. That's the function x squared minus 4x plus 7. And it's bounded by x is equal to 1 and x is equal to 4 and y is equal to 2. And we're rotating it about the x-axis. So again, I'm going to draw out this solid here again, just so that you can see it. So what I do is I reflect everything across to the other side. This is at 4, so I go to negative 4. And this is at 7, so I go to negative 7. This is the actual solid parts of my solid. And now I'm going to create my circles just so I can get a clear visual of the solid. I hope that kind of helps. I'm not great drawing on this program. Okay, so now let's figure this out. So we have here my outer function, right? So we always want to look at the function that is defined, not the part that I actually reflected. So my outer function is this parabola here, which is the x squared minus 4x plus 5. So I'm going to set up my equation here. Its volume is equal to pi from a to b, this is from 1 to 4, of my outer function, which is x squared minus 4x plus 7, minus the axis of rotation, which is 0, so minus 0 squared, minus now the inner function. The inner function here, that's y is equal to 2. So this would just be 2 minus the axis of rotation, which is 0. So 2 squared dx. Now before I can integrate, I'm going to have to distribute all of this. So I have to distribute this quadratic there. So that's the x squared minus 4x plus 7 times itself. And then minus 2 squared, which is 4. So let's go ahead and distribute this. So we get x to the 4th minus 4x to the 3rd plus 7x squared. Now I'm going to distribute the negative 4x, so minus 4x to the 3rd plus 16x squared minus 28x. Now distribute the 7, so plus 7x squared minus 28x plus 49, and then we can't forget about the minus 4 at the end. So now we can combine all of these things together. So we can write out our volume. Volume is going to equal to pi, the integral from 1 to 4 of x to the 4th. Then we have negative 4x to the 3rd minus 4x to the 3rd, which is negative 8x to the 3rd. Then we have 7x squared plus 16x squared, which is 23x squared, plus 7x squared, which will give me 30x squared. Then negative 28x minus 28x is negative 56x. And then 49 minus 4 is plus 45. So now I'm ready to integrate. So this is going to equal to pi times x to the 5th over 5 minus 8x to the 4th over 4, so 2x to the 4th, plus 30x to the 3rd over 3 is 10x to the 3rd, minus 56x squared over 2 is 28x squared, plus 45x. And I'm going to evaluate that from 1 to 4. So let's plug in the 4. We get pi. 4 to the 5th is 1024 over 5, minus 4 to the 4th, which is 256 times 2 is 512, plus 4 to the 3rd is 64 times 10 is 640, minus 4 squared is 16 times 28 is 448, plus 45 times 4, which is 180. And I'm going to subtract for when I plug in the 1. So that would be 1 to the 5th is 1 over 5 minus 2 plus 10 minus 28 plus 45. Now let's put all of these numbers here together. So we get pi times 1024 over 5. I'm going to combine all of these numbers here. So negative 512 plus 640 minus 448 plus 180 is negative 140, so minus 140, minus 1 over 5, and then I'm going to combine these here. Negative 2 plus 10 is 8, minus 28 is negative 20, plus 45 is positive 25. Distribute this negative, and we get pi times 1024 over 5 minus 140 minus 1 over 5 minus 25. I can combine these two fractions here, so that would give me pi times 1023 over 5, and then negative 140 minus 25 is negative 165. In order to combine, I would need to put these both over 5. So this is fine, but I need to put this over 5. So I'm going to multiply the numerator by 5. And I get pi times 1023 over 5 minus 825 over 5. Which when I subtract, I end up with 198 over 5. And can't forget the pi. And this cannot be simplified, so we would leave our answer just like that. Now let's look at another more complicated example. Here we want to find the volume of the solid when the region is rotated about the x-axis, and it is bounded by y is equal to x squared and y is equal to x plus 2. So this is our solid here, because it's bounded by just these two graphs. So it's this part that is solid. And we are going to rotate it about the x-axis. So that means that I'm going to reflect this solid over to the other side just so that we can get a clear visual. Since my axis of rotation is the x-axis, I'm just going to move these points equally to the other side. So we have the parabola that's like this, and then the line that goes through here. This part here is also solid. So now when I draw my discs, we get something like, whoa, that came out really bad. Let's try that again. So now I can draw those inner discs as well because you can see that there's a hole in the center. Whatever, close enough. This one is a nice representative slice because we have this solid part here and this solid part here, and then this here is that hole that's right in the middle. So let's see if we can figure out how to write out the volume for this solid. And I'm just going to erase this little part here so that way it's not in the way of our work. But you get the picture. So our volume is going to equal to pi. Now our limits of integration, we can see here that the solid starts at -1 because that is the point of intersection of those two functions. So we're going to start with -1 and then it ends here at the point of intersection, which is the x value of 2. Now, I never really remember the actual formula for volume. I just always remember it's big radius squared minus the little radius squared. So I look at my upper function, which is the line. So that's going to be x plus 2 minus the axis of rotation, which is 0, squared. Minus, now the little radius, that is the quadratic, because that's what's lower. So that would be x squared minus the axis of rotation, which is 0, so squared. So this is the formula that I would use to find the volume of this solid. So now I have to actually distribute everything. So we have here, I'm going to do that on the side. So x plus 2 times x plus 2 minus, and then this is x to the 4th. So let's distribute this out. This would give me x squared plus 2x plus 2x plus 4 minus x to the 4th, which I can now write out my equation for volume by combining like terms and writing it in standard form, which would be negative x to the 4th plus x squared plus 4x plus 4. And now I'm ready to integrate everything. So we have here the pi. This would be negative x to the 5th over 5 plus x to the 3rd over 3 plus 4x squared over 2 would be 2x squared plus 4x, and I want to evaluate that from -1 to 2. So now we're going to plug in the 2. So 2 to the 5th is negative 32 over 5 plus 2 to the 3rd is 8 over 3 plus 2 squared is 4 times 2 is 8 plus 4 times 2, which is 8. Now minus, I'm going to plug in now the -1. -1 to the 5th is -1, but we have this negative here, so it'll be positive 1 over 5. Then -1 to the 3rd would be -1, so it'll be minus 1 over 3. Plus -1 squared is 1, times 2 is 2, and then 4 times -1 is -4. So now we're going to combine everything as much as we can. So we have the pi. I'm going to leave these fractions until the end. So negative 32 over 5 plus 8 over 3 plus 16 minus 1 over 5 minus 1 over 3 minus 2. I'm going to distribute the negative now. So pi times negative 32 over 5 plus 8 over 3 plus 16 minus 1 over 5 plus 1 over 3 plus 2. Now we can combine as much as possible. Negative 32 over 5 minus 1 over 5 is negative 33 over 5. 8 over 3 plus 1 over 3 is 9 over 3, which is 3. Then 16 plus 2 is plus 18. I can combine these as well, so this would be pi. See, that's what I meant by why I do this at the end, because sometimes those fractions, when you add them or subtract them, whatever the operation is, you'll actually end up with a number that is divisible, and you won't have that fraction anymore. So we have this pi, and then negative 33 over 5 plus 21. So now we'll need to put this over 5 and multiply this by 5. So we get that pi times negative 33 over 5 plus 105 over 5. And now we just combine these two fractions together. Negative 33 plus 105 is 72 over 5, and of course the pi. And this would be the volume of that solid. Now we're going to continue with this example, but we're going to find the volume of the solid if it is rotated about a different axis of rotation, because all of the volumes that we've solved as of now, the axis of rotation has been the x-axis, which is 0. But instead for this one, we have here that the solid is going to rotate around the line y is equal to negative 2. So we're going to rotate that graph here. So this is the solid part, as we saw in the previous example. I'm going to reflect it over, so this is 3 units away, so I'm going to go 3 units down. This is 6 units away, so I'm going to get 6 down. And now I'm just going to draw basically more or less what it looks like, just so I can get a visual. You don't necessarily need to draw the figure if you just know that it's the outer function minus the axis of rotation, the inner function minus the axis of rotation. But I like to draw the figure because I like to see it. But again, you don't necessarily need to. And this here is what I'm going to use as my representative slice, this one here in the middle. So my big radius is, again, the line. But remember that when we're writing out the radius, it's the function minus the axis of rotation. So let's start writing out this equation for volume. So volume is going to equal to pi, the integral from -1 to 2, because that's where my functions intersect. So it would be my function, the outer function, which is the x plus 2, minus the axis of rotation, so minus -2, so plus 2 squared, minus, now my little radius is the function, which is x squared, minus the axis of rotation, so minus -2, so plus 2 squared. I can simplify this x plus 2 to be x plus 4. And I'll need to distribute everything. So that's what we're going to start off by doing. We're going to do the x plus 4 times x plus 4 minus x squared plus 2 times x squared plus 2. So let's distribute. First we have these two here, and that would be x squared plus 4x plus 4x plus 16. Minus, now because I'm subtracting everything on the outside there, I'm going to open a parenthesis to remember to distribute that negative. So this would be x to the 4th plus 2x squared plus 2x squared plus 4. We can combine like terms, so we get x squared plus 8x plus 16 minus x to the 4th plus 4x squared plus 4. Distribute the negative, and we get x squared plus 8x plus 16 minus x to the fourth minus 4x squared minus 4. So this is going to be what I'm going to integrate. So I am going to rewrite my volume equation now with my terms in order and combined. So we have the negative x to the fourth. Then I have x squared minus 4x squared, which is minus 3x squared. Then I have the 8x, so plus 8x. And 16 minus 4 would be plus 12. So now let's integrate. So we have this pi. Negative x to the fourth would be negative x to the fifth over 5. Minus 3x to the third over 3 would be just x to the third. Plus 8x squared over 2 would be 4x squared. Plus 12x. And I'm going to evaluate that from negative 1 to 2. So let's plug in the 2 first. We get pi times negative 2 to the fifth would be, well, 2 to the fifth is 32, so negative 32 over 5 minus 2 to the third, which is 8, plus 2 squared is 4 times 4 is 16, plus 12 times 2, which is 24. Now minus, I'm going to plug in now negative 1. Negative 1 to the fifth is negative 1, but we have this negative, so it becomes positive 1 over 5. Minus negative 1 to the third is negative 1, but it's minus, so minus negative 1 is plus 1. Negative 1 squared is positive 1 times 4 will be plus 4. And then 12 times negative 1 is negative 12. So now let's start combining these. We have again the pi, negative 32 over 5, negative 8 plus 16 is 8, plus 24 is plus 32, minus 1 over 5, and then 1 plus 4 is 5, minus 12 is negative 7. So I'm going to distribute the negative now. So this is going to be pi times negative 32 over 5 plus 32 minus 1 over 5 plus 7. I can combine these and I get pi times negative 32 over 5 minus 1 over 5 is negative 33 over 5. And 32 plus 7 is plus 39. I will need to put this over 5, so I'm going to multiply this by 5. And that would give me pi times negative 33 over 5 plus 195 over 5. So now for my final answer, I'm just going to add negative 33 plus 195, which is equal to 162 over 5, and then of course pi. And this would be my final answer. So notice the difference here now when our axis of rotation changed. It's always the radius minus the axis of rotation, and then you square it. Now let's see what happens when we change the orientation of the axis of rotation. So here, if the axis of rotation is the y-axis or is parallel to the y-axis, the integrand needs to be in terms of y, and the limits of the integration need to be the y values of the points of intersection of the curves that form the region being rotated. So basically, what does this say? This means that all the examples that we've been seeing here in the past, it has been rotated along a horizontal axis. So if it's rotated around a horizontal axis, our integrand, everything in the integral must be in terms of x. So horizontal axis, x. X is horizontal, so it kind of matches, right? Now, if now our axis of rotation is vertical, vertical are y's. So we would need to rewrite the integrand so it's all in terms of y. But our functions are never given in terms of y, they're given in terms of x. So we would need to change everything. Now let me draw this out so you can see exactly what I mean. Consider the region pictured below that is bounded by y is equal to the square root of x and y equals to x minus 2. Find the volume when the region is rotated about the y-axis. So we're going to rotate along this line here. And now I'm going to reflect it along that line. So here we have over there, and then this point here would be here. So it would be something like that. Oh, I kind of should touch more. There we go. And then here, so this is solid. This is solid. And then our discs, you see now look more like this. So when we are rewriting everything, and this we're not going to really do much work and you'll see why, but so our integrand, everything in the integral has to be in terms of y. So we have to take these functions here and solve for x instead of y. So if y is equal to plus or minus the square root of x, I would square both sides to cancel out that square root, and I get that y squared is equal to x. And then if I take y is equal to x minus 2, I would have to add the 2. So y plus 2 is equal to x. So these would be my functions now. Our limits of integration are still the points of intersection of the function, but instead of the x values, it would be the y values. So when we set up the integral, it would be the volume is equal to pi of the integral from the y value, which is -1, to the other y value, which is 4, and then we do from the axis of rotation, the outer function is the one that is the furthest away, which is the x plus 2. Y plus 2 minus the axis of rotation, in this case now is 0, squared, minus, and then a small axis of rotation, the small radius, which is the quadratic here. So this one here, y squared minus the axis of rotation, which is 0, squared dy. So this would be the integral that I would use to solve for the volume of this solid, which I did this on purpose because this is actually the same volume equation as this one here. It's just now it's y's instead of x's. So my answer would be the 72/5 pi. But I just wanted to, in this example, just emphasize how to write the integral. Now let's actually practice solving one. So we have here, consider the region pictured below that is bounded by y is equal to the cube of x and y is equal to x over 4. Find the volume when the region is rotated about the line x is equal to 9. Now I'm not going to actually draw the 3D figure just so that we can practice not having to do that, because I don't know if you'll be able to. So this is the line x is equal to 9. This is where we're doing our rotation. So this is the big radius and this is the small radius. So let's start off with taking these functions here, and because we have a vertical axis of rotation, that means that all of our equations must be in terms of y. So I need to solve for x. So we have that the cube root of x is equal to y. So I would have to cube both sides, And so I get that x is equal to y cubed. And that is this one here. So if you like, you can also label on your graph so that way it's easier to see. This is, I keep writing y equals because we're so used to y equals. So this is x equals to y to the third. And then the line here, that's x over 4 is equal to y. So I'd have to multiply 4 to both sides. So I get that x is equal to 4y. That's this line here. Then our points of intersection, remember we need to use the y values. This is a y value of 0, and this is the y value of 2. So now we're ready to write the integral in order to find the volume. Volume is going to equal to pi of the integral from our points of intersection, so 0 to 2, of my big radius, which is y to the third, minus the axis of rotation, so minus my axis, which is 9 squared, minus now my little radius, which is the 4y, minus the axis of rotation squared. So this is, and then obviously close your integral with dy rather than dx. So this is how I set up the integral in order to find the volume of the solid that will be formed. Now we're going to need to distribute all of this so that we can rewrite it in polynomial type form. So we're going to multiply y to the third minus 9 times y to the third minus 9 minus 4y minus 9 times 4y minus 9. So let's multiply that out. I'm going to do that over here. So y to the third times y to the third is y to the 6th minus 9y to the third minus another 9y to the third plus 81 minus, and I'm going to open my parentheses so I don't forget to distribute that negative. So this would be 16y squared minus 36y minus another 36y plus 81. So we can combine like terms, now well, distribute the negative and then combine like terms, etc. This is y to the 6th minus 18y to the third plus 81. This here, these two, negative 36y is negative 72y. So this would be, I'm going to distribute the negative now. It will be minus 16y squared minus negative 72y will be plus 72y minus 81. So now when I combine like terms, that's what I would end up integrating. So let's write out our equation for volume. It's going to equal to pi, the integral from 0 to 2 of y to the 6th minus 18y to the third minus 16y squared plus 72y, and then these 81s here cancel out. So it's just this equation dy. So now let's integrate. So we have pi. This would be y to the 7th over 7 minus 18y to the 4th over 4, which we can simplify that if you like. 18 over 4 can be simplified by 2, which will be 9 over 2. Minus 16y to the third over 3 cannot be simplified. Then plus 72y squared over 2 would be 36y y squared. And I want to evaluate this from 0 to 2. So let's plug in the 2. We have the pi. 2 to the 7th is 128 over 7 minus 2 to the 4th is 16. And 16 times 9 is 144. And then 144 divided by 2 is 72. So minus 72. Minus 2 to the 3rd is 8. And 8 times 16 is 128. And 128 cannot be divided by 3, so we're going to leave that as 128 over 3. Plus 2 squared is 4. And 4 times 36 is 144. Now minus when I plug in 0. But if I plug in 0, I get 0 minus 0 minus 0 minus 0, so 0. So now I just need to be able to combine everything here. I have these two different denominators, so I'll deal with that in a second. We have the pi. We have 128 over 7. I can combine this negative 72 with the positive 144, which is plus 72, and then minus the 128 over 3. So now I need to put this over a common denominator of 21. So I need to multiply this by 3 and this by 3. I need to multiply 72 by 21, and then this by 7 and this by 7. So let's rewrite this. This would be pi times 128 times 3 is 384 over 21 plus 72 times 21 is 1,512 over 21 minus 128 times 7 is 896 over 21. So now we combine all of these. When I add 384 plus 1,512 and then minus 896, that's going to give me 1,000. So 1,000 pi over 21. And this would be my final answer. And that's how to find volumes of solids through revolution.